Now the 3 is equal to the square of root of 3, and then minus the 2 times root of 3, and then plus 1 square. So by the square of the binomial formula, we have the a minus b square equal to a square minus 2ab and plus b square, right? So this guy, then we get the square of root of 3 minus 1. Okay, so it's kind of tricky here. So now this numerator becomes the square root of the square of root of 3 minus 1, and then divided by 2 times root of 2. So now let's take the square root of this numerator, then we got root of 3 minus 1 divided by 2 times root of 3. And let's continue to rationalize this fraction by multiplying both the numerator and denominator by root of 2. And then denominator root of 2 times root of 2, you have 2. 2 times 2, you have 3, or you have 4, right? So you have the 4 as the denominator. Then for the numerator, root of 3 times root of 2, you have the root of 6. And then negative 1 times root of 2, you have the negative root of 2. And you can compare the result we got in the section 3. They are same. Okay, you just got the same result when you use the half angle identity and also the cosine of a sum identity. Okay. Any question? So by now you have learned a new trick on how to do this algebraic simplification. Okay. And after we find the half angle identity for cosine, now let's look at the half angle identity for sine. And we begin with one form of the double angle identity for cosine. So we know cosine of 2x is equal to 1 minus the 2 times sine square x. And let's move this, okay, 2 times sine x to the left side, and the 2 and the cosine of 2x to the right side. So we got the 2 times sine square x equal to 1 minus cosine 2x. Then we divide both sides by 2. We have the sine square x equal to 1 minus cosine 2x over 2. Okay. Now let's take the square root of the both sides. Then we have the sine x equal to plus minus the square root of the 1 minus cosine of 2x divided by 2. Now let's replace x by half x. Then we get sine of half x equal to plus minus the square root of the 1 minus cosine. Okay, 2 times half x, you got x, right? So you have the 1 minus the cosine x, and then divided by 2. So this is the half angle identity for sine. And let's compare this half angle identity for sine with the half angle identity for cosine. So in the cosine case, we have the cosine of the half x equal to plus minus the square root of 1 plus cosine x over 2. So in the case of the sine, you have the minus sign here. In the case of cosine, you have the plus sign here. Okay? Now, let's look at the one example. Try to find sine of negative 20.5 degrees. Okay? And for this angle, you cannot use other identity we named before to find it. Okay? So now let's first rewrite this as the sine of the negative 45 degree over 2. So right now our x is the negative 45 degrees. Then by use this half angle identity, we can get. So now the question is, how do we determine the sign before this radical symbol? Same as the case of the cosine. Depends on the position of this half x. So we know if the half x is in the quadrant 1 or quadrant 2, then sine of half x is positive, right? So here, if the half x in quadrant 1 or quadrant 2, then you have the sine half x, okay, bigger than 0. And if the half x in the quadrant 3 or quadrant 4, then you have the sine of half x less than 0. Okay, so right now this negative 22.5 degrees is in the quadrant 4, right? So sine of the half x is negative. So we just take the negative sign. And then this is equal to 1 minus cosine x. And x is equal to negative 45 degrees. So you have the 1 minus cosine of the negative 45 degrees. And then divide this by 2. So now let's continue. So this guy is equal to negative. We know cosine of the negative 5 degrees, negative 45 degrees is equal to cosine of the 45 degrees because cosine is an even function, right? And cosine 45 degrees is equal to root of 2 over 2. So this numerator is the 1 minus root of 2 over 2 and then divided by 2. So now let's multiply both the numerator and denominator by 2. And then we get negative, okay, square root, okay, 1 times 2 equal to 2. And then this guy times 2 equal root of 2. And then over 2. Then we find the exact value of the sine of the negative 22.5 degrees. So since it's quite important to determine the sine when we try to use the half angle identity. So now let's see some examples about how to determine the sine when we try to use the half angle identity. And let's look at the page 543, problem 18. So this one, let me copy this problem on the whiteboard.